Okay, so today we're going to go backwards. Yesterday we knew some angle measures in a right triangle, and we solved for some side lengths using the three trig functions, sine, cosine, and tangent. Today we're going to go backwards. We're going to start with some side lengths and solve for some angle measures. To do that, we need to undo the operations we did yesterday. We're going to stay with the KISS method. If you think of this as like taking, if you have a squared function and you want to undo the squared function, you take the square root. You have multiplication, you want to undo the multiplication by dividing. Same thing is happening here. If I have a sine function, I want to undo the sine function using something called an inverse trig function. So it looks something like this. If you, for instance, if we go back to that triangle from yesterday, one thing we didn't talk about was how big is angle P or angle A? By the way, what's the relationship between angles A and P?
They're complementary.
Meaning?
That they add up to 90 degrees.
Good. So if I can find angle A or angle P, I could easily find the other one by just subtracting from 90. A lot of the secret of this stuff is making it as efficient as possible. Don't do big scary calculations when you don't have to. Okay. So in order to do that, like I said, we're going to use something called an inverse function. If you look at your calculator, above the sine, cosine, and tangent buttons, there are those buttons, the inverse function. Those are not reciprocals, those are inverse functions. They undo the trig function. Okay, got them? And you get to those by doing second sine, second cosine, second tangent. All right, so we'd like to solve. I think I'm going to solve for A instead. Now that's kind of a big jump, but let me go back to this picture here, and I'm going to solve for A instead of P. I would set up the exact same equation I set up yesterday, which would be the sine of angle A, and I could use any one of the trig functions. I just chose to use sine. The sine of angle A is 4 over 5, which is where this comes from. Now, starting out, I would probably rewrite it this way and leave some space in there. You'll see why in a second. My goal is to get A by itself. I need to get rid of the sine function. You get rid of the sine function by taking the inverse sine function because they will undo each other. However, basic rule of algebra, whatever you do to one side of the equation, you have to do to the other side of the equation. So I have to do an inverse sine of this, which now you see why I left space there. When I take the inverse of the sine, they cancel each other and leaves me with A on this side. This you do on your calculator. Please do that. Tell me how big angle A is. Can somebody confirm 53.13?
Yes.
Awesome. Okay. So how would you find angle P then?
Just do 90 minus 53.
Which would be?
36.87.
There you go. Now, that's not to say that we couldn't go back and do another trig calculation to find angle P. However, keeping it simple, we want to try and be as efficient as possible. I would argue that 90 minus 53.1 is a lot easier than setting up another trig function and solving for angle P. Any part of that seem difficult? Yes or no? No, it's just undoing what we've already done from yesterday. Okay, so solve this triangle. Now, when it says solve the triangle, it means when everything is said and done, you have all 6 chunks of information. All 3 sides, all 3 angles. I would start by drawing a picture. And then solve it. Go. sure you have your triangle labeled correctly before you proceed. What is that?
You can't. These screws versus? The last line. We never worked. We never worked. Okay, I don't understand how you would do it. No, you can't even do it. So,
Your method is correct, you just have the wrong stop.
that's
Just one.
cosine. Then it's just one. Adjacent then it's just one. So if it's 90, then it just moves 1 over 1. Then sine is 0. So sine 90 is 1. You can't do sine. You can just get hypotenuse over hypotenuse, which is 1. 1 over 1. The same thing over the same thing is 1.
Actually, x over x.
X over x is still x. No, x over x is 1.
All right, let's talk about this together because some of you have no clue what's going on, some of you completely rock it, and some of you made a couple minor errors. So that's what your triangle should look like. It doesn't have to look exactly like that, but it does need to be labeled like that. 13 is across from angle A, 18 is across from angle B, and C is the right angle. That's 3 chunks of information. Therefore, you need to solve for 3 chunks of information. What I would recommend, right out of the chute, is doing Pythagorean theorem, because I'm sure that you're going to do Pythagorean theorem better than you would do a trig function. C turns out to be the square root, was it 493? Yeah. 493. Now, you could include the approximate value of about 22.2, but I'm not going to use that for calculations. I can use 493, square root of 493 for calculations. Then you have a whole bunch of different ways to approach this problem. You need to find angle A and you need to find angle B. So let's suppose I want to solve for angle A. Why A? Because that's just what I chose. You could solve for angle B. But I can solve for A 3 different ways. I can solve for angle B 3 different ways. There are certain things that happen that will indicate that you did something wrong. So let's say, for instance, I'm solving for angle A. And I set up the following equation. The sine of A is equal to 13 over 18. No, I lied. 18 over 13. Hopefully you notice that that's wrong. It's wrong on a lot of different fronts. Number 1, it's the wrong function. Number 2, the ratio is wrong. But anyways, let's proceed. If I set this up incorrectly and I go to solve it, I have to do an inverse sine of both sides. So do that, please, on your calculator. Inverse sine of 18/13. So do that, please, on your calculator. The inverse sine of 18/13. What happens? You get an error. Why that happens and why you get an error is not really for us to discuss, but it is an indication that I did something wrong. It won't always give you an error. Sometimes it'll just give you an answer, but that answer will be wrong. So you have to be a little bit more careful with that. All right, so I'm going to solve for angle A, and I'm going to use, well, Abby, what did you use? Did you solve for A or B first? A. A. What function did you use? Okay, so sine of angle A should be 13 over the square root of 493. And again, I can use the square root of 493 because it's an exact value. I would not use 22.2. I'm assuming then you took the inverse sine of both sides. What'd you get for A? 35.84, and those are degrees. How'd you get B then? Did you do another trig function? Beautiful. So again, working efficiently, we know that angle B is going to be equal to 90 minus that 35.84, which would be 54.16. Okay, done. A lot of options. Once you find side C, again, 6 different possibilities to proceed through the problem. All of them will get you the same answers. It's just a matter of which one you're most efficient with. Okay, or which one you recognize. Like you don't remember, is tangent opposite over adjacent or adjacent over opposite? If you're not sure, then use a different trig function. Questions on this? Awesome. Next example. Make sure you sketch the situation first. And when we're doing realistic word problems like this, you can assume certain things like buildings, flagpoles, people are perpendicular to the ground. If they're not, it'll tell you specifically in the problem. We will do problems like that later, but just not right now. Mark just asked a great question. Why do we care that the eyes are 5.5 feet off the ground? Again, that'll become relevant once you get your picture drawn. So try drawing a picture and then solve it and see what you get for an answer. Then we'll talk about why that's there. Depending on how you solve the problem, or depending on how the problem is presented, it may or may not give that height. It's a good draw. That's perfect. Yes, sir.
I have a question.
Certainly.
So if you're trying to use sine, it's like if you're using sine underneath, it's opposite.
Never use a 90-degree angle. Creates all kinds That's perfect. We don't care about why. All we care about is X.
Okay, so stop what you're doing. Let's talk about the picture. If you're in this scenario, you have two options. You go out to the flagpole, you stand there with your eye 5.5 feet off the ground, and you measure the angle up to the flagpole. Or you lay down on the ground and put your eyeballs in the grass. It's entirely up to you. Either one works. It depends on how close you are with Mother Earth. So if you lay down on the ground and put your eyeball in the grass, you would have a picture that looks like this, because you're measuring it from the ground up to the top of the flagpole. But that's not what this scenario portrays. This scenario says, I don't want to get down in the grass and put my eyeball there. I'm going to stand over here. Ooh, you got a bend in your leg for some reason. And measure the height, or measure the angle up to the top of the flagpole. Which means I'm going to have some horizontal distance here from your eyeball straight across to the flag. What shape is this? It's a rectangle, so therefore how long is this segment I just drew? Hundo. This distance is 5.5 feet. This distance is 5.5 feet because it's a rectangle. And I'm going to call that distance x. So I'm not actually solving for the entire height of the flagpole. I'm solving for part of the flagpole, which is from my eye level up. And then I'm going to add 5.5 to my final answer. So go ahead and solve for x and tell me the final height of the flagpole. Question? You wouldn't.
This is supposed to be up there. Where did I solve What? You guys are dumb. That is supposed to be up there. What is? No. The angle up to the top of the flagpole is 37.5. Up to the top from there to Mr. Reedy. Is this is the correct angle? Or is that angle?
Yes, because you're measuring it from your eyeball. You can't measure that angle. I mean, how would you
That's what I
practice?
said.
Yeah.
Okay. Okay, how do you solve this? Okay, I forget about the word problem, but how do you solve this?
While you're solving this, let me ask you a question. Let's suppose instead of standing up, I do want to flop around in the grass. Would the angle increase or decrease if I was closer to the ground? Don't answer, just think about it. We'll talk about it when we're done looking at the value of this problem.
How do you solve this? Forget about the word. How do you solve that? That's what you can't solve that. You can't. Okay, so if I try to do cosine, okay, cosine is
Adjacent over I. No, okay, here. This
okay,
is solve for
so
y.
adjacent.
No, you do cosine c. That's what it is. Just
Cosine C, you can't use the 90 degree angle.
You could do the exact same.
I just labeled it.
So you and I
Cosine, but cosine is the highest value.
No, cosine is not hypotenuse. Cosine is adjacent.
Angle, it's adjacent over hypotenuse.
Yeah, I know. That's why it's 100 over y. I just made
Of which angle? The 90 degree?
Okay, look at it. Okay, just like get rid of this, okay? It's just like no point in having.
No, leave it.
It's adjacent over hypotenuse.
For cosine.
Over hypotenuse. Adjacent over hypotenuse.
I know that, but you don't know what that.
What?
Holy shit.
Okay, answer? No, not
How do you
yet.
solve that? 100 over y. Cosine 37.5.
Y over here. Y cos.
So how do you just put it over there? Do you multiply?
Any other answers? Information?
What do you? Yes,
Ooh,
it
different
does.
answer. 82.2. Anybody else? Tiebreaker?
How?
The third answer, 120 what? Okay. 75.3. Another answer.
I see divided by y.
I got 82.2.
Y.
Let's go!
So what did you do?
5 equals 100.
Tangent.
And that divide by 37.5.
Opposite over it.
100 divided by.
Cosine 31.
Okay, 100.
That's exactly.
Trent, what's X?
X is like without. It's 76.7.
126.
Wait, but like, you get these. Wait, just to read.
Why can't you go x over 100?
Here's your 37.5 degrees.
What?
Wait, why can't
So notice, this is somewhat of a realistic problem. If it's a realistic problem, I wouldn't know how to measure this angle up here, shy of climbing up on the flagpole. And if I climbed up on the flagpole, I wouldn't measure that angle. I would just measure the height of the flagpole. So therefore, you're going to measure it from your eye. You got to be careful when you set up these problems. Okay. So now the question that I was talking with a group over here, and the question is, suppose we were out doing this, or I should say, suppose when we're out doing this, and one person decides to stand here. Let me get this out of the way. However, another person decides, I'm going to flop around on the ground. Where would they have to lie in order for the angle to be the same? In other words, if I extend this, it'll hit the ground somewhere. Notice that these lines are parallel, yes. They're both horizontal. And I want to keep this angle the same because those are corresponding angles. Where would I have to lie in order for the angle to be the same and us to get the same height of the flagpole? Is that a calculatable answer? Can you solve for this distance? Yeah, you can. Okay. We're not going to do it. I'm just presenting a similar problem. Questions? Beautiful. Next example. Solve for x. Notice it doesn't say solve the triangle, it just says solve for x. Many of you are solving for the third side of the triangle. The question I have for you is, it's not needed information. Now, you could solve for that third side of the triangle if this setup isn't a trig function you like to use. By the way, with that picture, would I use sine, cosine, or tangent? Cosine, adjacent over hypotenuse. However, if you don't like cosine for some reason, you could solve for the third side and use sine or tangent.
He just said it.
Little help, please.
The negative one.
51.3, somebody confirm?
Yeah.
Yeah.
And those are degrees.
31.
Oh yeah, there we go, 51.3. Good job. Okay. Also, not a 30, 60, 90 triangle. And there's no indication in the problem that it is a 30, 60, 90 triangle. But suppose it was. And suppose I wanted to know something like that. What's the sine of 30 degrees? So go ahead, plug it into your calculator, see what you get for an answer.
0.5. 0.5.
Also known as a half. Some of the what's called unit circle trig problems you can use your calculator for. The question is, why is it 1/2? Other than your calculator does some magic and spits out an answer. You should, however, be able to answer that question if you had that, which is the general form of a 30, 60, 90 triangle. You'll notice that the questions I'm about to ask you, all three of these, are based on 30, 60, and 45 degree angles. So again, why is the sine of 30 1/2? Trey?
Because sine is opposite over hypotenuse.
Yeah.
And if you have the 30-degree angle, then it's gonna be a over 2a, which is just 1.
Well done. Okay, that having been said, what's the cosine of 60?
Okay.
Same thing. How about the sine of 60? Let's try that one.
0.8.
Nope, calculator no good here. I want an exact answer. Who's talking? Is that you, Evan? A square root of 3 over, which is? So a square root of 3 over 2a, which equals what? Because that's not a numerical value. That's based on the size. What's that? Root 3 over 2. The a's cancel. Okay. So the general form allows you to set up a value for any size triangle, okay, where a is some value. A could be 1, a could be 1,000,000, it doesn't matter. Okay, but it does get it down to this value. Now, if you take the square root of 3 over 2 on your calculator, you'll get 0.8 something or another. But again, we want an exact answer. Okay, last example. What's the tangent of 45? Well, you might need that. Now what's tangent of 45? Why, other than your calculator told you?
Because
So you know, on a quiz, I'm not going to ask you for the sine of 30, the cosine of 60, or the tangent of 45, because your calculator gives you the answer. I'm going to ask you something like, what is the sine of 45? Because this is too easy. Your calculator just spits out the value of 1. But what is the sine of 45? That's a better question. Say again?
Or a over a root 2.
Which equals? Thank you. 1 over root 2. Okay, that's a better question. Because if you type the sine of 45 into your calculator, you get, I think it's 0.707, is that right? That's not good. We want the exact answer of 1 over the square root 2. Okay. And this is all based on something called the unit circle, which you will cover, I think, in pre-calculus. Might come up in algebra 2, but I'm not sure. Okay, we're all done. We good? Yeah. Now you throw all this into one big bag and stir it up, and it gets a little confusing. Am I solving for sides, or am I solving for angles? If you're solving for sides, you want to use the sine, cosine, and tangent. If you're solving for angles, you want to use the inverse sine, the inverse cosine, and the inverse tangent. Yoke. Day 5.
We're solving for sides, you use opposite.
No, for angles.